Welcome back to the Scotti-BYTE channel, and this is Scott. Last time I introduced you to the Minisforum UM350 16GB small form factor PC that might be used for self-hosting in your home lab. After the initial configuration and allowing for a burn-in period, I migrated a few of my existing applications to it. During the migration, I made a few decisions as well as some discoveries. This video should be helpful if you are either adding your first server or an additional server to your home lab. We are going to look at which applications I moved to the new server and see a demo of the working system. So, LXD containers, as we've learned, are quick and easy to deploy, pre-built images, and they do not require an operating system installation process. One key decision during the LXD init process prior to creating containers is the creation of your storage pool. And here I have a screenshot from a previous video where I created the storage pools with the LXD init command, and you can see that I chose the default, and the default is a ZFS storage pool, and I did not opt to give it an additional disk or partition by answering no to this question, which is the default, and so it created a ZFS volume inside of a file, which by default was 30 gigabytes. So the storage pool in LXD handles all of your contents of your container file systems. Unlike most file systems, ZFS uses pooled storage, which combines the features of a file system and a file manager. ZFS can span multiple drives, and storage is easily added, and formatting is handled by ZFS automatically. ZFS performs a copy on write when data is to be changed, unlike typical file systems, which just overwrite your data. This means that new information is written to different locations on the disk, and once the write is complete, the metadata is updated to point to the new data. If a system crashes during the write operation, the old data is preserved, and so therefore ZFS is less likely to experience data corruption. We learned on the channel that LXD supports container snapshots, and ZFS can also use snapshots to track changes to its file system. Whenever data is written to a ZFS volume, a checksum is created, and ZFS can automatically attempt repairs based on those checksums in the event of an error. ZFS can also handle RAID without requiring any extra software. RAID Z requires at least 2 data drives and an additional parity drive, just like RAID 5 does, but RAID Z is its own protocol. And ZFS is popular in large data centers because it uses a 128-bit address space, and the largest ZFS volume can be up to 256 quadrillion zettabytes. And if you're wondering what a zettabyte is, it's 2 raised to the 70th power, so that's a little bit larger than your average floppy disk. So in my LXD storage pool, we are creating a ZFS file system inside of a file for LXD to store its container file systems. So the size of the ZFS default pool created during the LXD init command should be able to store all of the file systems for all of your containers in total. So I'm running 8 containers, which I chose as core applications that I decided to move from my other 3 larger LXD servers. First of all is the Cast the All Things server, or CAT server for short. A CAT server is a GitHub project, and what it does is it allows you to take the contents of a web page or of a video and cast it over to a Google Chromecast device, and I use that in my home automation. Secondly, I have a custom server called Camera Image Web Server, and on my front porch I have a camera, and I also have a motion detector. And when motion occurs on the front porch, it snaps 8 quick images of whatever's on the front porch, and it stores them as a motion event on that web server, which can be periodically reviewed, and it stores all motion events for up to 2 weeks in a row or longer if I choose. And then the next one is a Harmony API. That's for the Logitech Harmony Hubs, of which I have 3. And if you're familiar with the Logitech Harmony Hub, it is a fantastic remote device. And unfortunately, Logitech has decided to discontinue it. But by default, when you use a Harmony Hub, it launches what are called activities. An activity is basically a switch to turn on peripherals and set their values as far as the inputs and devices that are used to listen to sound on. Well, what I have is with the Harmony API, I have device level control. And for some of my automations, I required device level control. And so this API is called by some of the things that I'm running on the network in my home automation. Next, I have the Heimdall dashboard. If you watch Brian's awesome open source channel, Brian has featured Heimdall many times in the past, and Heimdall is basically a dashboard for your local area network and its applications. Next, I'm running an application called Monitor. Well, this one's a little bit older application, and what it does is it monitors the uptime status of websites and web-based programs. So in this case, I have so many containers running hosted applications that Monitor gives me a single web page at a glance to tell me what the status of those applications might be, and I can easily see if something might be down. And next, I run something called Monocle Gateway. So Monocle Gateway is an app that performs an RTSP to RTP gateway for video, and it's designed to be able to host cameras that Amazon by default will not work with all third-party cameras. And in my case, my cameras are either all Reolink cameras or they are Ubiquiti Unify cameras, and those cameras are not supported by Amazon. So the Monocle Gateway allows me to be able to have voice commands to display those cameras on my Echo Shows or on my Fire TV or Fire TV sticks, and it allows a display of full resolution HD or 2K displays. The next application is Nginx Proxy Manager, or NPM. So Nginx Proxy Manager, or Reverse Proxy Manager, is extremely important in hosting applications. We've discussed this on the channel before. And one of the problems I was having is that I was shutting down or configuring my other servers, and if one of those servers was hosting NPM and it went down, all of my applications went offline. So I've decided to move this very important application over to this server, which in general I don't plan to do any maintenance on or play with separate apps on other than a rare once in a while. And finally, Hoogle. So Hoogle is a private search engine that basically looks at results from Google, but does not send any metrics back to Google and also doesn't accept any ads. And it allows you to do searches within your web browser that are essentially somewhat more private than you would have had otherwise. Anyway, that's the 8 applications I'm running there right now. So let's go take a look at what I actually did. So here we are at a command prompt, and we're going to start an SSH session with VMS Mist, which is my Minisforum UM350 that we installed the other day. When I log in, you can see that my current utilization is 13.9% of the disk space on my 512 gigabyte disk that I replaced the stock 256 gigabyte NVMe drive with. The current memory utilization is 29%, and that's with 8 containers up and running that have real applications in them. The temperature of the system right now is 24 degrees Celsius. I've not found that this gets very hot, but it is in a very cool room also. And you can see that the address for my bridge device is 172.16.1.50. We talked about how to configure the bridge in the last video. So we can do a LXC list and see all 8 containers that are up and running on this machine. The CAT casting server has its own dedicated address on the main LAN, which is 172.16. And then the camera image web server is on the IoT network, which is the 30 network. The Harmony API is also on the IoT network, but you notice that it has a Docker inside of it because the Harmony API is a Docker application which I've nested inside of LXD, which I kind of consider a best process that I've discussed on the channel before. And then Heimdall is a network-wide dashboard. If you watch Brian's channel, Awesome Open Source, he frequently talks about Heimdall and what a nice desktop dashboard it is. And I've got it implemented in a separate container also because you can see that it is a Docker application and the Docker network is listed here as well. One of the things that I like about nesting Docker applications inside of a dedicated LXD container is that gives each application its own unique address that I can place on my main LAN or on any of my VLANs. Next, we have the Monitor application, which is also another Docker application, as you can see here, and it's presented to my main LAN. And then my Monocle Gateway is not a Docker application, it's a dedicated application, but you can see that it has an address on the 30 network, which is my IoT VLAN. And then my Nginx Proxy Manager is actually on my main LAN. And then finally, I have my Hoogle, which is my search engine, and it is offered on my 80 VLAN, which I refer to as my Cloud DMZ LAN, and it's where my public services are offered. And here we are on my LXD dashboard, VMS Mist. The actual LXD dashboard is hosted on a different device, but this lists the fact that there are 8 containers and all 8 containers are running. And I've not yet created any LXD virtual machines, which are different from virtual machines, but we've covered that on the channel before. And the current utilization of memory is standing at about 31% of the 16 gigabytes. So if we click on containers, again, just like with the LXC list command, you can see all of the containers listed. But what's particularly interesting about this display is the memory column, so you can see how efficient each LXD container really is. For example, the CAT casting server is taking 114 megabytes, and that's the application and container running. The camera image web server is 154 megabytes, and so on down the list. It looks like the largest app that I have here is my Heimdall, and it currently is taking 528 megabytes. Of course, when these apps are under load, they'll take a little bit more. And then the root disk, whenever you create a container, you create a root disk, and that root disk goes inside the ZFS storage pool, and these are the sizes of the containers as they stand now. My largest happens to be Nginx Proxy Manager, and it's about 10.5 gigs, and also my Harmony API is 10 gigs, and I think that's because they have a lot of log file information that they do clear out periodically. But most of my containers, as you see, are just a gig or under. So here's my Camage Image web server application, and you can see that what it does is it captures motion events from the camera on the front porch based on the motion detector that's there. And in this particular case, it's capturing 6 frames in a row, and it captures each as a separate motion event. So we can click off to other motion events, like let's say we go to 1:57 in the morning, and we look here, and if you saw in that picture really quickly, if you look really fast, you'll see that there's a possum that comes up here to the porch. Maybe if we check another one, we'll see that. There's the possum. Okay. So we catch all kinds of interesting critters at night, cats, raccoons, possums. We put out a little bit of cat food for the local folks. Anyway, just kind of an interesting application. Here is my Harmony API app. That's another Docker container that's running inside of one of the LexD images. And you can see here that it is looking at my master bedroom hub and my family room hub. And it provides me device level control for those things that are attached to my Harmony hubs. Here's my Heimdall dashboard, and you can see that I have a number of my self-hosted applications being displayed on it, and it gives me sort of a network-wide dashboard that can be accessed from any of my devices. Here's the Monitor app, that is monitor with 2 R's, and this shows a display of all of the devices on my network that offer some kind of a web page interface, and it monitors the status of those and lets me know whether any of them are unreachable. So since I have so many LexD containers that offer web-based services, it's nice to know when something is offline at a glance. And of course, here is my Nginx Proxy Manager, which you'll recall is a Docker application also nested inside of a LexD. You can see that I have 28 reverse proxy hosts and 1 indirection host defined on my Nginx Proxy Manager, which is now moved down to VMS Mist. And finally, we have the Hoogle container, which is a self-hosted search engine, so I can look for Scotti-BYTE, and we'll see what this brings up. And of course, it brings up the Scotti-BYTE website, and we can click on it and go there. So Hoogle's a really nice search engine. You can see all my margins are nice and clean. There are no ads anywhere out here, and also no log data being sent to Google. So back in the SSH session on VMS Mist, you can see the btop command has been executed here, and the CPU is largely idle. It seems to run about 0 to 5% with even all 8 of the containers running. And it also seems to run a temperature of around 28 degrees Celsius, and it can go up to about 31 or 32. It'll drop back. Once in a while you see what I think is a spurious setting when it says it's 36, because I don't really think it's getting that hot. You can see that the memory utilization is at 30% right now. Recall that when I built the system, it reserves 2 gigabytes out of the 16 gigabytes for the integrated graphics, but I disabled the integrated graphics, so I got back basically all 16 gigabytes. And at this point, my 8 containers, some of which have a memory cap of up to 6 gigs apiece, all of them in total are running in a really small memory footprint, and it's only taking up 30% of available memory. And the disk space at this point is pretty much negligible as well. The other thing that I wanted to point out is I wanted to go in and look at the LexC profiles. The reason I wanted to do this is because I realized that when I moved my containers from one system to another, I did a LexC export on each container after stopping it, and then I did a LexC import on this device to bring the container online. Well, before I could do that, I had to make sure that this system had the same profiles that I was using on the system it was coming from. So I have a profile called bridge-main, which is used to offer things bridged to the main network LAN. I have a IoT profile, and the IoT profile offers containers in address on the IoT VLAN, and I have VLAN 80, which offers containers on VLAN 80, which is my cloud DMZ VLAN, as I mentioned earlier. And of course, the default profile is a standard profile that's part of any LexD installation. So in summary, today we learned why a ZFS storage pool for LexD is a really great choice. We learned that ZFS is a file system and also a storage manager. I moved 8 containers to the new system, and the memory utilization runs only about 30% of the 16 gigabytes of memory. And we learned about some considerations in moving LXD containers across systems. The Minisforum UM350 is a nice, cost-effective hosting server in a small form factor, decent performance, and offers expandability. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.